Hi students, now we will discuss about the types of the error. As you are aware that different type of errors might be occurring while you will perform some of the experiments in physics or maybe in chemistry or in a biology as well. But we are talking about the types of the errors occur during the physics practical. Very first one is called as a systematic error. Next one is called as a random error, and third one is called as a gross error. Systematic error contains because of so many various factors. Very first one is called as because of the instrument. So first of all, whenever you will deal with the physics practical, you must be aware about that what type of error that instrument possesses, because in physics gradually you will learn that year by year our instrument can create such type of a smaller to larger errors. Because of that, its a nature would be there. Next one is called as into that it is called as a method error. That systematic error into that, if you are just following a wrong method, if you will perform this experiment for interval of a time or numerous amount of time, again will lead to the one error that is called as a systematic error, and you cannot reach to your final destination, means actual result. Then third one part is called as a personal error. If someone is okay with the method, okay with the instrument, but personally is not okay with calculation, so he may or she may leads to that another part that is called as a personal method. So whenever you are performing any type of practical, be careful that personal error may not lead to that wrong observation. Next one is called as a natural error. As you are aware that nature is the only predominant factor which is not allowing you to read your 100% observation, so it's called as a natural error. Because of that, it is somehow called as the external error sometimes, because nature is always playing its role and it's a predominant part. So natural error is also part of a systematic error. And last not least, you will whenever measuring small radiuses, so for small radiuses you will just take two other instruments. One is called as vernier calipers, and next one is called as our screw gauge. So these are the two instruments. You will just use this two element material, and they will give you that very smaller radiuses and smaller diameters. So it's one part, it is called as a least count measurement. So whenever in a practical lab you will be handed over two instruments, first of all ask to your practical teacher about its least count measurement, or is called as LCM. So these are the part whenever you are just performing any experiment, systematic error may occur. Next part is called as a random error. That random error is called as because of that irregularity. Whenever you are performing any experiment, you are very much cautious. Your instrument is either errorless, ideal instrument, your method is perfect, you have taken care of everything, but even though you are just handed over to some of the error, this error is called as irregularity, because it may come or may not come. And the last one is called as a gross error. So in the gross error, what you will be doing is that it is called as your final result is affected. Because of very first one is that you haven't taken proper observation. Next one is your method is not proper. Next one is called as your formula or equation which you have to be calculated is not perfect. And last one is called as your ideal values. So whenever you are just performing any type of practical in your practical lab in the school, you have to be very careful that your systematic random or gross error may not hinder your practical. So these are the only just give you the glimpse or idea how your practical can be performed. But yes, in physics we are just calculating number of observation. So very first and second thing is that we are taking care of is that we are taking more number of observation. So whenever number of observations are more, it means that there are less chances that your error can be there, or you can calculate and eradicate error. The next one is that one method we will follow to just eradicate our practical errors. So we are just taking care of this thing, error occur knowingly or unknowingly. We have some method how to just calculate it. So first of all, what we are just using is that very first part is called as absolute error. In this error, let's say I'm just performing one experiment and I'm taking some observation A1, A2, A3, A4 and A5. Then absolute error is called as sum of all observation divided by number of observations. So I have taken 5 observations A1, A2, A3 and A4. I am just doing their summation divided by their number of observations are 5. So generally you can just say that A, and it is called as its mean, it is called as the sum of all observation of this one and divided by its ratio of numbers. So you can just say that A mean equals to sigma ai by n. So basically up to your 10th you are just saying that it is called as average method. So this is one type of thing. You can just say that absolute error is called as a sum of your observation divided by number of observations. Next one is called as our mean absolute error. In the mean absolute we are doing nothing else. We are just doing taking what? We are taking that A mean minus first observation is denoted by delta A1. Then we are taking A of mean minus A2 is equals to delta A2. Then A of mean minus A3 is called as a delta A3. Then we have A of mean minus A4 is equals to delta A4. Then we have A of mean minus A5 is called as a delta of A5. It means that we are taking our previous answer minus our all observations will give us such type of data. I am putting in a modulus part because I want that mean absolute must be positive. So I am just mentioning that now delta A of a mean absolute is a sum of delta A1, delta A2, delta A3, delta A4 and delta A5 divided by number of observations like our average. So what I did is that taken that my previous expression of mean and then subtraction of all my previous observations which are there, and then it is giving me some answer which must be positive. So sum of all divided by number of observation will be my delta A of mean. Now my third portion after mean of absolute is that I am taking that ratio of both my mean absolute and absolute, that is called as third one is called as relative relative error. In this one I am just mentioning by delta of A is called as a del of A, which is called as a mean absolute divided by absolute error. So I can have a delta A of mean of a previous one, this one by the ratio of this one. So it will give me delta of A, that is called as a del A. And now the fourth one is called as a percentage error, that is called as a relative error multiply by 100%. So I can get that delta A multiply by 100%. So these are the four steps. Whenever you have taken numerous amount of observations, means more and more observation, so you may just calculate it out and it will give you that proper solution or proper measurement. Let's say for your conveniency I am just mentioning that one example for you. Let's say I have performed one experiment and its values are like very first experiment contains that periodic time, and there are observations are 2.63, then 2.56, then I have a 2.42, then I have a 2.71, and I have 2.80. So I have such type of method in front of me and I want to just calculate it out. So what I am doing is that it's a calculation. Very first I am just finding it out that I am just mentioning this all r as a t. So I can have a delta t mean. I have to find it out. Then I have to find it out t mean. I have to find it out delta t and its percentage. So first of all I am just using this one t mean. So I can have a t of mean is equals to 2.63, 2.56, 2.42, 2.71 and 2.80 whole divided by 5. So I can get that t of mean is equals to 2.624. Let's say this is my first answer. This is the first thing. Next I want to just find it out delta t of mean. So you are aware that what I have to do is that first of all I am putting a bracket t of me minus t of 1, t of mean minus t of t2, t of mean minus t3, t of mean minus t4 and t of mean minus t5. It means that I have just found it out all my data of t of a mean. So I can have a t 2.62 minus my initial data was a 2.63. So it would be 2.63. Next would be I have a 2.62 minus 2.56, 2.62 minus 2.42, 2.62 minus 2.71 and 2.62 minus 2.80. You can see that in an after a few clips we will just learn this thing to just do a round it off. So what I did is that taken all those datas. Now I am just calculating that a modulus of 2.62 minus 2.63 and because of I have just taken a modulus, so it will give me that positive value 0.01. Then I can have a 0.06, then I have 0.20, I have then 0.09 and this one will give me negative, but because of the modulus I have 0.18. So this is called as a delta t. It's the first part I have just done. Now I am just doing it's the average part. So let's say I'm just taking delta t of mean. So I have all those data in front of me, so I'm taking all those data first of all, and this is called as 0.01, 0.06, 0.20, 0.09 and 0.18. I have just taken all those values into the modulus, that is why my answer would be positive. So that is called as a 0.05. So I got sum of all these thing is called as a 0.54 divided by 5. So I got that delta t mean is equals to 0.55 by 4. So I got 0.11. So this is my second answer. uh, Now third state is called as a delta t. I want to find it out. So I'm just taking that ratio of my absolute and mean part, delta t of mean divided by t of normal mean, which was previously this one is 0.11 and that was previously I have is called as a 2.62. So I am just putting that 2.62. So it may give me delta t is equals to 0.041. I am just mentioning plus or minus because in later part we will just use that notation. Last part is called as I want to find it out percentage error. So for the percentage, what I am doing is a delta t multiply by 100%. So I have a plus or minus 0.041 multiply by 100% will give me plus or minus 0 point sorry 4.1 percentage. So this is how we can find it out our type of error in the terms of whenever average part is there. So students, I am giving you one more example, just go through that part and calculate by your own method. Let's say I have one observation that is called as a 1.29, 1.33, 1.34, 1.35, 1.32 and 1.36. For this much part you have to just find it. Let's say I'm just naming it as n1, n2, n3, n4, n5, n6. First of all, just give me that answer of n of mean, then delta n of mean, then just find it out delta n and delta n multiply by 100%. So go through the method which I have shown you, and it may lead to your answer that for this one you will get 1.3275, and for this one you may get 0.02. For delta n you may get plus or minus 0.0015, and this one would be your 0.15 percentage. So go through that method I have just shown you, and you will be capable enough to find it out how you can take a number of observation and how you can calculate it. So students, after this clip you will be capable enough to learn that what type of mistakes people are committing during their practicals, and with the method when number of observations has been taken, and you can eradicate it. In the next clip we will just go through some of the formula which are dealing with the errors. Thank you.